Now let's look into the various applications of Poisson's distribution. So where data scientists can take the leverage of this distribution. So the Poisson distribution is a probability distribution that's commonly used in data science and has applications in various fields. And you can see some of those here. So the first one is count data analysis. The Poisson distribution is often used to model count data such as the number of calls to a call center, the number of accidents in a day, or the number of customers arriving at a store. Then we have quality control. The Poisson distribution is used in a quality control to monitor the number of defects in a product. For example, if a company produces 10,000 items and the Poisson distribution predicts that an average of 10 defects will occur, the company can use this information to monitor the quality of their production process. And third one is insurance. So insurance companies use the Poisson distribution to model the number of claims that are filled in a given period. So this information helps them to determine the amount of money that they need to reserve to cover potential losses. Then we have the traffic engineering. The Poisson distribution is used in traffic engineering to model the number of vehicles that pass through a particular point in a given period. So this information is used to design and manage traffic flow systems. And epidemiology. So the Poisson distribution is used in epidemiology to model the number of cases of a disease in a given population. So this information is used to predict the spread of diseases and develop effective disease control strategies. So in summary, the Poisson distribution is a versatile probability distribution that has a wide range of applications in data science and other fields, but we are worried only about the data science. So now let's look into the one example in detail. So one example where data scientists might use Poisson distribution is in modeling web traffic. Modeling web traffic. So web traffic is often modeled using Poisson distribution since it involves occurrence of events, website visits over time. So by using Poisson distribution, data scientists can analyze the number of visits to a website and make predictions about future traffic patterns. So that's where the Poisson distribution comes into the picture. So for instance, let's say a data scientist is analyzing the website traffic for an e-commerce company. So they can use Poisson distribution to model the number of visits to the website per hour or per day. So they can then use this model to predict future traffic and optimize website resources accordingly, such as the server capacity to handle the predicted traffic load. Additionally, they can use this information to plan marketing campaigns and promotions around the peak traffic times. So that's where the Poisson distribution comes in handy for a data scientist. So let's look into the one. So one more example. So I have coded this. I have written the code because I don't want you to take a lot of your time. So so this is the example using the Poisson distribution to model the number of customer arrivals at a bank during different hours of the day. Basically, if anybody is working, any data scientist who is working with a fintech company or a bank, so this one would be very useful. The Poisson distribution will be useful for you. So the model that I have taken is uh, to model the number of customer arrivals at a bank during different hours of the day. So as usual, NumPy matplotlib. Then I have generated a random data from like for the number of customers arrival during different hours of the day, 25, 30, 60, 70, and then this is what no we got. Okay, at different hours of the day. So now let's fit a Poisson distribution to the data. So lambda is equals to NP of the mean arrivals. Let me show you what's the lambda for us. So lambda, it's lambda underscore, yes, it's 58.75. This is our lambda. This is the mean arrivals. This is the mean arrivals. Now after that, I have fitted this model into the Poisson distribution. So now we can see the Poisson distribution. So length of arrivals. So let's plot the data and Poisson distribution together. So subplots, and one here you can see the observed data, and here you can see the Poisson distribution. So both you have, one is observed data which is actual real, and other one is Poisson distribution. In some cases it's pretty close, and this portion you see that this portion is exactly same, and this portion is somewhat closer. You see that till this portion is somewhat closer, and here again closer. So that's what is a Poisson distribution. That's how it will be useful. So in this example, we generated data for the number of customer arrivals during different hours of the day, and then fit a Poisson distribution to the data. We then plotted the observed data and Poisson distribution to visualize how well the distribution fits the data. So numpy dot random dot Poisson function was used to generate a Poisson distribution with the same mean as the observed data.